Hi everyone, Assalamualaikum. In this video, we will continue with example 5a under evaluating limit x approaches infinity fx over dx equals to infinity over infinity. Find limit x approaches positive infinity such 3x squared minus 1 over 2 plus x. Let's say if we use direct substitution, we plug in infinity into variable x here. So, we will get infinity over infinity, which is indeterminate form. So, in this case, we cannot use direct substitution, right? Since we are given limit at infinity, so we can solve this limit using shortcut method, right? When we use shortcut method, we just choose the term containing highest power of x in numerator and the term containing highest power of x in denominator. Okay, so we can write equals to limit x approaches infinity radical 3x squared over x. Okay, and then from here we can separate the radical if in between is multiplication operation. Okay, so from the properties of radical, we can write equals to limit x approaches infinity square root of x squared times square root of 3, okay, over x, right? Right, from here, if we have square root of x squared, it means equals to modulus x. Modulus means we can take positive or negative value, okay? We will take modulus x equals to positive x if x greater or equals to 0. And we take modulus x equals to negative x if x less than 0. Okay, so from here, okay, since we have positive value here, means x approaches positive infinity, means x is positive. Okay, x is positive means x greater or equal to 0. So we can write such x squared equals to modulus x. And then modulus x equals to positive x because now we solve limit x approaches positive infinity means that x is positive value. That's why we choose modulus x equals to positive x here. Okay, we just leave set 3 as set 3 here because set 3 is not a perfect square, right? After that, we can simplify x from numerator and x from denominator, right? Right, after we simplify, we get this. Limit x approaches infinity, constant set 3, right? Since there is no variable x to substitute here, so the answer equals to set 3, okay, which is positive value. Okay, we just leave the answer equals to set 3. Okay, no need to write the answer equals to decimal value. Alright. Right now, we continue with example 5b. Okay, we use the same function, but now we want to solve limit x approaches negative infinity. Right? Right, so from the given question here, if we use shortcut method, we just choose the term containing highest power of x in numerator and the term containing highest power of x in denominator. Okay, so we can write like this. Limit x approaches negative infinity, set 3x squared over x, right? And then, using the properties of radical, if we have in between is multiplication operation, we can separate the radical. So we can write set 3 times square root of x squared and then over x. Okay? Right. From here, we have square root of x squared equals to modulus x. And we choose modulus x equals to positive x if x greater or equals to 0. Okay? And we choose modulus x equals to negative x if x less than 0. Right? Right. So from here, we write square root of x squared equals to modulus x. Okay, but we just write cert 3 here because cert 3 is not a perfect square. Okay, no need to solve. Right? Alright, from modulus x here, which one we want to take? Is it positive x or negative x? Okay, so look at this. Okay, from here we have x negative because we have limit x approaches negative infinity. Means the value of x is negative. Okay, negative means x less than 0. So when x less than 0, we write modulus x equals to negative x. So from modulus x here, we write equals to negative x here. Right? So we have limit x approaches negative infinity and then negative x cert 3 over x. Right? And after that, we can simplify x in numerator and x in denominator. Right? And then we can move out constant negative 1 here. Negative here means negative 1. We move out from limit expression. Okay? So we get this. Okay? Equals to negative limit x approaches negative infinity cert 3. Right? Now we have limit of constant. Okay? So the answer equals to constant, but we have negative sign here. Right? So the final answer equals to negative cert 3. Right? From example 5a, the final answer equals to positive cert 3 because we solve limit x approaching positive infinity. But in example 5b, we solve limit x approaches negative infinity. And the final answer here, okay, after we choose modulus x equals to negative x, we get the final answer equals to negative cert 3. Okay, same magnitude but opposite sign, right? Coming up next, limits at infinity for a rational function. You can subscribe, like and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.